And this is chapter, no, this was just a quiz. Quiz questions. Allie, I believe I saw your hand go up. Stripes. Number 10. Ah, yes. Sometimes it's just frustrating. You might look at a problem over and over and over again and just not see the pattern. 3 over 1, 6 over 2, 9 over 6, 12 over 24, ... 24 over 40320. Okay, so let's start with what I think is the easy one. If I go across the top, what is the pattern here? Add 3. On and on and on, right? So if I wanted to write a formula for just the top, I could say the nth term is the first term plus 3 times n minus 1. And if I were to simplify that, that would just be 3n. Okay? And then 3 times what gives me 24? 8. So if I were to just think about this from the top, if this is my first term, second, third, fourth, I would be looking at the sum from 1 to 8 of 3n. That's just the top, though. That's not the whole thing. So now we're going to look at the bottom. From 1 to 2, what is that? Multiply by 2, 2 to 6. Anytime you see that where you're multiplying the next number, that's n factorial. Okay, so 1 factorial is just 1. 2 factorial is 2 times 1. 3 times 2 times 1. 4 times 2 times 1. And if you're worried about this guy, check to see if the pattern holds. Grab that number and see if that is 8 factorial, which it happens to be. Okay? So that is the answer for number 10. Leanne. Stripes number 4. Okay? And I was really kind of generous on this guy because I've looked back at what the other teachers are requiring and I'm just kind of being stupid apparently. But 8 choose 5 can technically just be typed into your calculator. But what we're looking at here is this, the formula for this is 8 factorial over 5 factorial. What is the difference between 5 and 8? 3. So this is 8, 7, 6, 5 factorial. 3, 2, 1. The 5 factorials cancel out. 3 goes into 6 how many times? 2. And I'm going to go ahead and cancel that 2 out also. And 8 times 7 is? Okay, 56. 56, yes. Or, grab the calculator. Since I didn't say on that one to show your work, I did accept 8 alpha F2, 8, 5. Boom. I did accept that guy. Okay? Yes, ma'am. Stripes 8. You stripies didn't like your quizzes, apparently. Okay? This was one of our n factorial problems. So 8 said n minus 2 factorial, n plus 3 factorial, over n plus 2 factorial, n factorial. Now let me ask you, when you do these problems, do you pair them up or do you look for the absolute smallest one?
I look for the biggest one.
Okay, so you do the pairs is basically what I'm saying. Yeah, okay. I just wanted to make sure I did it whichever method you did. So which is the absolute biggest one?
N plus 3.
N plus 3, and that's the biggest one on the top. Who would it pair up with? N plus 2, because we're looking top to bottom, we always have a pair. So I'm going to deal with that pair first. Which one is bigger? N plus 3. So I'm going to take N plus 3, and I'm going to write that out until I get, which happens to be the next number, N plus 2. And I do that because very easily those guys will cancel out. That leaves me with another pair. Which of those two is bigger? N. So I'm going to write that out until I get, whoops, E goes on the bottom, not on the top. I'm going to write that out until I get the N minus 2. So that's N minus 1, N minus 2 factorial. Again, those will cancel out. So what I'm left with is N plus 3 over N times N minus 1. Some people multiplied that out, some didn't. I don't care. Yes, ma'am. Sure. Stars or stripes? Stars. Finally a star. You're such a star in my book. Gag. All right. So, and this is a really good question because questions like this are on your review and possibly on your test. So let's go through it. And I kind of like that extra credit because I figured you should probably be able to get either 10 or the extra credit. Some people got both. They were both kind of difficult, so you had that option. So the extra credit said the second term was 24. The seventh term is huge. And we're looking for R, which should tell me what kind of a thing am I dealing with here. We're going for geometric, right? And geometric, my formula says the nth term is the first term or any other term times R to the N minus 1. So I'm going to grab these pieces here and put them in. So I'm going to have the seventh term, the second term. I'm looking for R. What's going to go up here? 7 minus 2. So I have 186,624. It's 24 times R to the fifth. How do I start solving this? Divide by 24. So I have no idea what that is. Let's see. 186,624 divided by 24. So now I have 7,776 equals R to the fifth. Now, there's a couple of different things you can do here. You can sit there and play until you come up with what number to the fifth gives you 7,776. Or, if I'm trying to solve an equation that has a variable as a base, what can I do? Last unit. ln, thank you. ln. We can ln both sides. That would bring the 5 down. And I would have ln 7776 is 5 ln r. So I'm just going to type this in my calculator. I'm going to do ln 7776, and I'm going to divide that by 5. So now I have 1.792 is ln r. And how do I finish that type of an equation? E! E! So I'm going to do an E on both. That'll cancel that out. So R is E to that power, basically 6. And we can check to see, is 6 to the 5th power that number? And it is. Or you could literally just sit there and go, okay, 1 to the 5th, 2 to the 5th, 3 to the 5th, 4 to the 5th, 5 to the 5th, 6 to the 5th. Oh, look, there it is. And you can't see any of that, so you should tell me when that happens. I don't care how you get there, just that you get there. Okay? Does that help a little bit? Any other quiz questions? I mean, you guys did really, really well on that. I'm very quite proud. And again, you kind of had the opportunity, and I really did think that you would have trouble on probably one or the other. And if you had trouble on both, well, that's probably not a 100 anyways. Yes, ma'am. Quiz star number 9. Sigma notation. All right, so number 9 gave me 5 plus 11, 17, all the way up to 71. Can you see my pattern here? Okay, what's going on? Add 6. And when we add 6, what kind of a sequence or series is it? Arithmetic. So you can say the nth term is the first term plus 6 times n minus 1 and get -1 plus 6n or 6n minus 1. Or you could just kind of figure out that as I go through this, if I'm constantly adding 6, what number do I need to add 6 to get 5? -1 plus 6n. So it's the same idea here. And then I need to figure out what n is. So I'm going to say 71 is 5, first term, plus the difference, times n minus 1. And then when you go through and you solve that, you're going to end up with n is 12. So this is the sum from 1 to 12 of either 1 minus or -1 plus 6n or 6n minus 1. Okay? How are we doing? Yes.
I don't have a question.
Okay.
But what was the answer of the time?
On the stars? Sum from 1 to 8 of 2n over n factorial. Okay. All right, so let's take a look at your review then. I did have your answers posted. There were a couple of mistakes in there that I found since going through them, but let me just go this way because they're posted. And if you wanted the answers, you would look. Tell me, questions, any problems that you went, oh dear Lord, what is she asking me to do? Yes. Number 14. Kai. Woo! Yay, that's a fun one. You're like, no, it's not. It's math. It's not fun at all. Number 14 asked to find the sum of the series where it went 9, 1/3. They didn't actually have pluses there. 1/9, 1/27, ... And we were asking for the sum. What is going on here? Is this arithmetic or geometric? Geometric. Because what do I have to do? It's missing a term. Yeah, it's missing a term. Is that what the problem was? Yeah, it should be 3, 1. So this is the reason why you had an issue on that one, is it should go 3, 1, then 1/3. And without that, it doesn't work. So that might have been what your problem was. Do you want me to continue working it out? No, it's fine? Sorry about that. Yes, ma'am. Meep, 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 meep. Number 6. Ooh, I love these problems. Oh my gosh. Okay. Number 6 says there's a pyramid of cans that has 42 cans on the bottom and 3 less each row. We want to know how many cans are in the 12th row. The first thing you need to identify is, am I talking about a term or a sum? A term. Because otherwise I would have said, how many cans are there if there are 12 rows? Okay? So we're looking for the 12th term. If I'm constantly adding, or what am I doing? Am I adding 3? I'm subtracting 3. I'm subtracting 3 from each. I start off with 42. And I'm going to say 12 minus 1. And just plug that sucker in. And you're going to have 9 cans.
See, I thought 42 was like the last term on the first one, so that's why I was...
Yeah, it is kind of weird. The way they're talking about it is they're saying, okay, there are 42 in this row. My next row up is going to be 39, 36, up, 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 up. So they're looking at 1, 2, 3. Okay, and if you need to, draw a little picture like that. To me, it helps a lot if that's what they're calling the first row. Okay. Next. You guys are just so thrilled to be here this morning, this beautiful Monday morning. Angie, 34. Okay. Yep, he's an ugly one. 34 gives me 4 over 1, 9 over 8, 16 over 27, 25 over 64, 36 over 125, and we're trying to write that in sigma notation. Just start with one of them. Let's look at the top. How can I get 4 and 9 and 16, 25, 36? All of those are what? Perfect squares. So this is 2 squared, 3 squared, 4, 5, and 6. Okay, so that's the first thing we need to notice. Ugh, what about the bottoms? Cubes. That's 1 cubed, 2 cubed, 3 cubed, 4 cubed, and 5 cubed. So to find this, the term in sum notation, and it says we have to start from 1. This one starts from 1. This one goes up as high as 5. And so that means the bottom, I'm just going to have whatever number I'm talking about cubed. Now, the top is something squared. But if I'm talking about 1, how do I get 2? If I'm talking about 2, how do I get 3? Talking about 3 to get 4? Plus 1. So there's the answer to that guy. Okay? Start, before you think about this stuff, just say, okay, what's going on? Can I find what the pattern is? Then try to figure out how can I write the pattern as an equation. Anybody else on any of these? Did anybody else do them? No? No? All right, so we're going to stop here, and I'm going to let you guys spend some time working through these together then. Questions from the problems that you've done so far on the review? Yes, ma'am. The answer for 13 was 365. Oh, that's 12. It's ugly. I'm going to write it down so that you can see it because it's crazy. So 53144 over 177147. Could I do 13? Let's do 13. Okay, give me a second. I need to try to. It's not focused very well. So, number 13 says we're looking for the sum of the first 12 terms in the series if the first term is 2/5 and the ratio is -1/3. And it says write your answer in simplified fraction form. So the formula for the 12th sum is the first term times 1 minus the ratio to the 12th power all over 1 minus the ratio. So far, so good? Okay. Now what I'm going to deal with, I'm going to focus on just the easy pieces because I think that's going to be nicer. I'm going to deal with just this stuff here because I have a feeling that the calculator might not be able to handle that fraction. Is that correct? Calculator basically went, what are you doing to me? Yeah. So what I've got here is I have 2/5 divided by minus a minus becomes a positive, and 3 times 1 is plus 1. That's 4/3. Okay, because this is the same thing as saying 3/3, right? 3/3 plus 1/3 is 4/3. So this is the same thing as saying 2/5 times 3/4. So far, so good? Okay. Now, 2 goes into 4 how many times? Twice. So I have 3/10 is this stuff right here. The rest of this is going to be kind of icky. So let's figure out if I'm going to say a negative to an even power, is that going to be positive or negative? That's going to be positive. So I'm going to have 3/10 times 1 plus, what is 1 to the 12th? And 3 to the 12th is the icky part here. This is why the whole thing kind of crunches to a screeching halt. So 3 to the 12th is 531,441. Okay? So far, so horrible? You guys want to cry yet? So let's see if the calculator can handle all of that. Actually, and we want to do this in fraction form. So 3, no, over 10 times 1 plus 1 over 531,441. So it still doesn't like me yet. Okay? So it's basically forcing me to do this. And I don't want to do it, but I'm going to do it. So I'm going to take this number. To get 1 plus this, I'm going to say this times this plus that. So 531,441. What am I doing? I don't even need to add that. Lord Augsburger. So that's going to be 531,442. Yeah, that was special. Leave me alone. Meanie pants. So let's see what happens here. I'm going to try to simplify this. 531,441. Let's see if that divides by 3. Yes, it does. So 3 goes into this and leaves me with 177,147. I know 10 doesn't go into that. You agree with me on that one? But what does? What goes into both those numbers? 2. So 2 goes into 10 5 times. And so this is going to be 265721. That is not the answer that I have.
Did you divide the... No, that's right.
Yeah, I might have just left it. That's okay. I was copying somebody else's answers in all honesty, and that's never a good idea. So here I have 265721 over 5 times 177,147. Helps if I actually type it in right. 5 times 177,147. And let's see if that simplifies. 265721 885735. It won't let me do that, so I'm just going to stop here. Dear God, no. I would never do that to you. That's horrible. That's cruel and unusual punishment right there. Blech. Oh, no, I see what my problem was. That was supposed to have been a minus. Because a negative to an even power is positive. There was a negative sign out in front. And it's going to change the answer so teeny weeny weeny weeny. So this is going to be, again, I can do this without a calculator. So now the 10 does go into it. So yeah, I was right the first time. One stupid sign mistake does all of that jazz. Thank goodness for erasable pens. I'd like to hug whoever came up with them. Just give them a big old hug. Thank you. All right, sorry about that. One stupid sign mistake does all that mess. Biscuits, exactly. Anybody else? Questions so far? Yes, Alex. I knew you had a question bubbling up inside. Okay. Ooh, good one. 33 is a tricky one. So I've got 2/3, 6/6, 24/12, 120 over 24, 720 over 48. And we want to write that in sigma form. Technically, if I was going to write that in sigma form, they should all be pluses between them. Okay, so again, break it up. Don't try to think about it all at once. Which one looks easier to find a pattern, the top or the bottom? The bottom, definitely the bottom. And if I'm going to start with 1, 3 is, 6 is, this is 3 times 1, this is 3 times 2, that is not 3 times 4, or 3, what is that? That's 3 times 4. Okay, this is 3 times 8. And this is 3 times... What is this? 3 goes into 48 how many times? Okay, all right, so that one doesn't work. Or it does work, but it's a little bit harder. I could have also done this to say from 3 to 6, what do you do? Times 2. Times 2. Times 2. Times 2. Sorry about that. It is. There are different ways to get this. I realized that once I got started. So what I can think about this is 3 times 2 to the n minus 1, right? Everybody okay with that bottom part? Now on the top is a little bit different. What do I do to 2 to get 6? 6 to get 24? 24 to 120? 120 to 720? And when we do that, when we're constantly multiplying by the next number up, what is that? That is a factorial. But this isn't 1 factorial. It's 2 factorial. This is 3 factorial. So if I'm going to start with 1, that's got to be n plus 1 factorial. So that means this question, if I start from 1, I go up to 1, 2, 3, 4, 5. The bottom is 3 times 2 to the n minus 1, and the top is n plus 1 factorial. Insane in the membrane. Insane in the brain. 3 times 2 to the n minus 1? Because this here is geometric. First term is 3. Common ratio is 2. Okay. I would not do a combined problem that difficult on the test. You might have a problem with factorials, problem with geometric, but I probably wouldn't combine geometric and factorials at the same time. Okay? Which is what I was just looking at. All right, any other questions, or you just want more time? More time. All right, go for it. More time. 17. Okay. No, this is not a stupid question. This one's tricky because of the way you have to solve this. The sum of the series is what we're looking for on number 17, where we have 3, 3/2, 3/4, and we're going all the way up to 3 over 6, 5, 5, 3, 6. Okay? All right. Now, what is going on in each of these? 1/2. Yeah, so that's your ratio. So if I look at this, I know that my first term is 3. I know that my ratio is 1/2. The problem is I need to know what n is. So I know that I have a whole lot of terms here because I get all the way up to 6, 5, 5, 3, 6. And this is actually the hardest part of this question, is solving for that n. So the formula we have says that the nth term is the first term times the ratio to the n minus 1 power. So that means I'm going to have 3 over 6, 5, 5, 3, 6 is equal to 3 times 1/2 to the n minus 1. Now, what would you do first to solve this? And I'm going to actually consider it in terms of 1/3, simply because I think it's easier to think about that way. So those guys cancel out. And now I have 1 over 6, 5, 5, 3, 6 is equal to 1/2 to the n minus 1. And that's a booger. That's kind of weird to solve if you've forgotten something. How do I solve this equation? ln, yeah. So I'm going to take the ln of each side, and that pen is deceased. And that's going to let me pull that thing down in front. So it means I'm going to have ln of 1 over 6, 5, 5, 3, 6 is equal to n minus 1 ln of 1/2. Now I think it's easier here to just divide both sides by ln of 1/2. So I'm going to plug this into my calculator because it's going to be icky if I don't. And I'm going to say ln of 1 over 6, 5, 5, 3, 6 divided by ln of 1/2. Oh, that's nice. I got 16. So 16 is n minus 1, so what is n? 17. But if you've forgotten that step, or if you get intimidated by the numbers at that step, it's like, no. Gets a lot trickier. But this isn't what the question was asking me to do. The question was asking me to find the sum of those guys. So that means I'm finding the sum of the first 17 terms when the first term is 3, 1 minus 1/2 to the 17th power over 1 minus 1/2. And let's just see, maybe, thank you, maybe we are in a nice enough world that that's going to work out. I have no idea. So 3 parentheses 1 minus 1/2 to the 17th, whoops, divided by 1 minus 1/2. That is not the answer that I have. Did I type that in right? Okay, let me try this in the pretty fraction way. 3, 1 minus 1/2. So it's ugly, and it's not the answer that I have. I got an answer that is 100% wrong because it's 131,071. So that's not right at all. Oh, you got 15 for n? No, I know for a fact my n is 17. Because when you distribute your n minus 1 here.
Is that a minus?
Yeah. All right, ladies and gentlemen, so what happens next class?